Hello everyone. In this video, we're going to discuss how we're going to combine what you have learned in the first few videos into solve a circuit that's made up of resistors that's connected in series and also connected in parallel. So in a way, when they're combined together, how do we analyze such questions? We're going to break down piece by piece. So in this circuit here, we are supposed to find V1, V2, I1, I2, I3. In this specific example, we don't have resistance because we don't want to mix up too many, we don't want to complicate matters. Just focus on current and potential difference. Now let's take a look at, let's try to find V1 first. Okay, let's try to find V1. Look at 4 volts and look at these two resistors. I highlighted in yellow. Okay, these two resistors. Now we know these two resistors are connected in parallel. Okay, these two resistors are connected in parallel. And therefore, because they are connected in parallel, V1 has got to be equals to 4 volts. Because those two resistors are connected in parallel, and potential difference when are equal for two resistors connected in parallel. Then how do we find V2? So for V2, pay close attention. Okay, pay close attention. I'm going to draw some more things on this diagram. It will look a bit complicated, but once you get it, it's actually quite easy. Now to obtain your V2, we must see what is the EMF of the battery. We see the EMF of the battery to be 9 volts. Okay, to be 9 volts. So using the 9 volts, we know the EMF across the two resistors in parallel and that V2 has to be, the total potential difference has to be 9 volts. So because the two resistors highlighted in yellow are parallel to each other, they're parallel in connection, sorry. It's wrong to say to each other, they're parallel in connection. The potential difference at these two junctions, the potential difference here is actually 4 volts. You only consider one because they are the same connection, same junction. And therefore that makes this potential difference 5 volts. Therefore V2 equals 5. I say again, for the two resistors that are connected in parallel, the two highlighted in yellow, the potential difference across each resistor is 4 volts. But because they're connected in parallel, you only consider one of the voltage. The reasoning behind this is, well, potential difference. So the difference, this junction, the difference between these 2 points, I highlighted in purple, are the same. They're potential difference. They're the same, right? So you only consider 4 volts. How about the potential difference? How about the current I1, I2, and I3? Now the current I1, I2, and I3 is a little bit easier because we look at current split at the junction, whether they split or not. First look at the 5 ampere. 5 ampere, after it leaves the resistor, it has to be 5 ampere. And if current flows along one path, it enters the battery as 5 ampere. Leaves the battery as 5 ampere. Therefore, I1 equals 5 ampere. How about I2? 2 ampere leaves the resistor at 2 ampere. So before it leaves, it enters as 2 ampere. Now current I1 arrives at this junction, circle in red, and is split into two. 2 amperes flows across one of the resistor. So the other current has to be 3 ampere. And therefore I3 equals 3 amperes. What I've shown you here is you have to identify the current flow to know whether it's a series of parallel connection and then solve it along the circuit. So you have to teach the idea of applying formula, stuff like that. And it's not going to work. Okay, it's proper analysis of a circuit.